Okay, so we're going to go over 2.1, a bunch of questions here. So 1, 3, 5, 12, 22, and 25. So the very first question is graph the function over the domain of that, which sounds really crazy, but in reality, they just want you to graph in a very small window from -4 to 4. That's all they're saying. So when I graph a function, the very first thing that I do is I just actually just start plugging in some points. Okay, so I'm going to start building a table. And this is actually what I'll do. I'll build a table. Oh no, I'm frozen. Oh, I would build a table. So I'm going to build a table by hand because technology is not going to work. So I'm going to put some numbers in anywhere from -4 to 4. So I will start with -4 and I'll see a pattern, I'm sure. You will see a pattern, which is more important. So then I'm going to plug all those in and then I'm going to see what happens. So of course, I'm going to use my handy dandy calculator to help me plug in. Desmos graphing. I don't know why it's not known. Oh, because I'm on that one. It's fine. Okay, so I'm going to start plugging in this. You should know what 2 to the -4th actually means. You don't need your calculator, but here, that might help you, do this. If the negative exponent is impeding you from moving forward, use a calculator. Okay, so 2 to the -4th, I know is just divide by 2 4 times. So that's going to be 1/16. Okay. So 2 to the -4th, you see, yeah, it's some small number. Okay. And then same with -3, that's just going to be 1/8. And then this is going to be 1/4. This is going to be 1/2. Anything to the 0 is 1. This is 2, 4, 8, 16. So you can see that this goes really, really small, and then all of a sudden it hits, and then it grows super quick, right? So graphing this function, right, 2 to the x, at this point, I would like you to have this picture in your head, really close here, and then all of a sudden it hits the x-axis, the y-axis, and boom, it grows, right? So that's exactly what this graph does. So I'm just going to scooch this over and then show you. So I'm going to just graph a couple of these points. 0, 1 goes right here. 1, 2, 2, 4, 3, 8. And then 4, 16. There it goes right there, right? So this is kind of my picture. And of course, it's very laggy. Okay, it'll catch up. And then when I graph these little guys here, if you notice, I'm just going to get closer and closer and closer to my x-axis. Okay, closer and closer. So it'll look like this thing. And then I just graph my little curve in. Same thing goes for this one. Okay. Number 3, 1/2 to the x is actually pretty funny, right? Because you're like, oh my gosh, what is this thing gonna do? So again, I'm gonna use my little table. And then it's said to use from -4 all the way down to 4. So I'm gonna plug in all these numbers, right? My computer is very laggy. Hold on. Okay. So I drew a table and I'm going to plug those values into there. When I take 1/2, this is your reminder, when I take 1/2 to the -4th, that actually means 1 to the -4th over 2 to the -4th, right? So remember when I say that negative means you're dividing by it? Well, you can also think about it as it sits there, it's going to be when you divide by a divide, because you're going to have a 2 to the -4th on the bottom right here. It's not showing you. There it goes. Yay. right? Oh, what happened? There it is. So it's gonna divide by -4. Sorry, divide by 2 4 times. So if you divide by a divide, that's like multiplying by the reciprocal. So the 2 to the 4th ends up being on the top. And same with that 1 to the 4th, we're dividing, right? So 1 times 1 times 1 times 1, that's just 1. So my denominator is pretty much just a 1. And then now 2 to the 4th goes on the top, right? So 2 to the 4th is just 16. So over here, my answer is 16, right? Okay. So when I graph this, it makes sense to me that these numbers are basically these numbers here, except flip-flopped, right? 16's at the right here, and 1/16 is on the bottom. So I'm just going to write those out. So 8, 4, 2, 1, 1/2, 1/4, 1/8, and 1/16. So it kind of looks like a reflection of this guy, right? It kind of looks like a reflection. So I'm just going to graph it. There you go. So actually, when I graph this, 1 divided by 2 to the x, oops, that's not where I wanted it. Nothing went where I wanted it to go. So to the x, do you see how that looks, right? So there goes that. OneNote is very laggy right now. Hold on a second. So that'll show up eventually. So there goes that. It says compare problem 1 to problem 2. Multiplying by 2 should generally, no, let's see. I wouldn't do number 5 because it's asking you to compare these two. So if you look at these two, when you compare it by 2, I would just use my calculator. So let me show you. Let me just plug this guy in really quick. So 2 times 2 to the x. Look at the purpley guy, this darker colored one, compared to this guy right here. See how he's a little bit taller, So the question was, compare problem 1 to problem 2. Multiplying by 2 should generate a vertical stretch of the graph, but the graph looks like it has been translated vertically. How do you explain that? So it actually hasn't been translated vertically, because if that was true, then this asymptote here would have moved up 1. Remember, we talked about shift up 1, but it hasn't, right? But why does it look like it moved up 1? Well, it looks like it moved up 1 because this point right here, my 0, 1 guy, is now at 0, 2, right? So everyone's like, oh, Ms. Johnson, it's going to be a shift up. If that was true, then your asymptote would also move up, and it didn't, right? So instead of going from 1 to 2 by adding 1, we're going to go from 1 to 2 by multiplying by 2. You see that? If I said, hey, what did you do to 1 to get to 2? There's a lot of answers, right? One of them is +1 and another one is times by 2. So be comfortable in knowing that when you're writing these equations, you got to look for all your clues. For these, you're looking for your asymptote and your point. Like, remember, that's what we were doing today with logs, right? Look for your asymptote. What's your asymptote telling you? What's your point telling? Where did that 0.10 go? Okay. The next question someone asked was number 12. So here's number 12. It says, given f of x, just go like this. Given f of x equals 5 to the x, use the table to fill in the missing values and evaluate the log expression. Okay, so this is very similar to that other one that we did before, and it was looking at the graph of it, right? So here it says f inverse of 25 means log base 5 of what? Equals what? Right? So if if the function is 5 to the x, then the inverse, what's the inverse? In the chat, can you tell me? If the function is 5 to the x, what's the inverse? No. Yeah, log base 5 of x. Very good. So in case you don't know this yet, right? These two in your head, oh man. I think that like my OneNote is all caught up to me and it's not. Hold on a second. Okay. So right here, I have written that f inverse of x equals to log base 5 of x. Log base 5 of x. Okay. So you should know in your head 5 to the x and log base 5 of x are inverses of each other, just like multiplying and dividing, just like adding and subtracting. There it goes, right? So these two, if you don't know that these two, 5 to the x and log base 5 of x, are inverses of each other, they undo each other, then make sure that that's at the top of your screen. You write that every single time you start homework, you write that down. So one of the things that I used to do as a student is whenever I learned a new concept, at the top of my homework, I put the things that were important. So this is definitely something I would put at the top of my paper, right? So, okay, so f inverse of 25, right, means log base 5 of 25. Oh, so you want me to put 25 there? Yes. So here you can either figure this out. 5 to the what gives me 25. 5 to the what gives me 25. And someone already in the chat wrote 2 exactly. Or the other way to do it is when I get out 25, what did you put in? 2. So that goes there. Does that make sense? Okay, so similarly, f inverse of 3,125, log base 5 of 3,125, right? I don't know 5 to the what gives me 3,125, but this table showed me. So what is this answer going to be here? Yeah, it's going to be 5. Very good. Okay, now this one says, I'm going to get a 1. Now, Ms. Johnson, is it this one or this one? Where was this 2? Oh, the 2 was here. So where is this one? Yeah, this guy right here. So what did you have to take the log of to get 1 as the answer? Yes, a 5. Does that make sense? So this is going to be log base 5 of 5 is 1. Got it? Let's see. You didn't ask for that, but I still did it because that made more sense to do it. This is what we did already. And then you asked for 22. Okay, go back here to 22, right? Can someone rewrite that for me? 4 to the negative third. 4 to the negative third. What is it telling you to do? What is 4 to the negative third telling you to do? Yeah, dividing by 4 3 times. So 1 over 4 cubed, right? Find equivalent numerical expressions that no longer have exponents. Okay, and then they want you to multiply 4 out. So 4 times 4 times 4 is 64. So my answer is 64. Okay. Okay, very good. All right, next question. Next question is 25. Okay, so 25. The very first thing the biggest thing I see is this 0. What's anything to the 0? Yeah, it's just 1. Very good. So this whole thing is 1, Miss Johnson? Yes. So what's 3 times 1? 3. So I wrote a 3 here, but you can't see it because my computer's slow.